In today's video, I'll be going through some questions that are usually asked in the exams. These questions are based on Euclidean geometry, circle geometry in particular. So let's get to the question. In the diagram, chords KL, and LP and KP are drawn in a circle centered at O. Okay, this is our center. It's also said that SLR, this line here, is a tangent. So if SLR is a tangent, it simply means that if we're to draw a line here that passes through the center into the other end, in other words, if we were to draw a diameter, then we would have 90 degrees on either side of the angles that would be formed here. Okay, now let's read the question. The question is saying, prove the theorem which states that the angle between the tangent SLR, so here, and chord KL is equal to the angle in the alternate segment, that is, prove that SLK is equal to P. So what we want to prove is that this angle here is equal to that angle there. So before you prove that this angle is equal to that angle, you've got to know some things first that would then lead you towards the proof. So what I would suggest is that we should first find an expression for SLK. So SLK is going to be equal to, but remember, before we make the proof, it's imperative that we draw first by construction a line that moves towards the circumference and cut the circle into two halves. In other words, we have to draw this diameter here. We can call this M, where it meets the circumference. Then we can also draw another one here. This is going to be MP. So this is 90 degrees as a whole. So this is 90 degrees. But then we want SLK. But then there's this small portion here. This small portion is KLM. So we can say 90 degrees minus this small portion is going to be equal to SLK. So 90 degrees minus this small portion, which is KLM, is going to be 90 degrees. And we are doing this calculation because of the assumption that we have 90 degrees here. And that is also based on the fact that this is a radius, this is a tangent. So this is radius perpendicular to tangent. The reason this is 90 degrees is because this radius here is perpendicular to the tangent. And now the second one would be to look at LPK, this angle here, this whole angle here, LPM, yes, let's look at LPM. So if we look at LPM is going to be equal to, let's look at it, LPM as a whole is going to be equal to 90 degrees. It's because if we were to isolate this angle, this triangle here, we would find that ML is a diameter, and a diameter will always subtend a 90 degrees angle at the circumference. Let me draw it here for you so that you can see it. So we have this circle here, this one, and then we have diameter ML, and then we have this line here. I'm going to draw it this way. This line is going to be drawn this way. So this is going to be 90 degrees. That's what I'm saying. So this is 90 degrees here. That is that's LPM. Now we're not interested in this whole thing. We are only interested in LPK. LPA is going to be equal to 90 degrees minus KPM. So it's going to be 90 degrees, the whole angle here, minus this small angle here. So it's going to be 90 degrees minus KPM. Oh, and by the way, we should give a reason for LPM is equal to 90 degrees. It's because angle at the circumference, angle at circumference. Okay, so that's the angle at the circumference. And now this is going to be 90 degrees minus km, of course. Now, because we want this angle to be equal to that one, remember we have to prove that this angle here, LPK, is equal to SLK. We want to prove that. We need to write this expression such that it's the same as this one. So what can we do in this equation so that it becomes this equation? This expression, not the whole equation, but just this expression. So if you look at, let's consider KPM. So consider KPM. KPM is equal to, let's look at KPM. If you look at KPM is this angle here. So if you look at KPM and you also look at this other side here, you'll find that KPM is equal to this angle here, KLM. Why? Because they are formed by the same segment, segment KM. So KPM is equal to KLM. The reason for that is angles formed by the same segment, and then that means LPK is going to be equal to 90 degrees minus, and then in the place of KPM we're going to put KLM. So that's going to be KLM. So now you can see that SLK is equal to 90 degrees minus KLM. LPK is also 90 degrees minus KLM. Therefore, SLK is equal to LPK. Remember, LPK, if you look at this is LPK. LPK is essentially P. So we can just say SLK, this is P, is equal to P. So SLK is equal to P. That's how you prove it. Now let's go to the next question. Okay, in this question we are told that PWRS is a cyclic quadrilateral. If PWRS is a cyclic quadrilateral, then we assume that R1 plus R2, which is this side here, plus P, their sum is going to give us 180 degrees. And also this side here and this angle, they are also going to give us 180 degrees when you add them together. That's what quadrilateral, that's the significance basically of being a cyclic quadrilateral. Okay, let's continue. And it's centered at OP. And we also told that triangle PSW is an equilateral triangle. PSW is an equilateral triangle. Therefore, all its sides are equal, and these angles are 60 degrees. So that's the information we need there. So this whole angle here, W1, W2, and W2 are 60 degrees as well. And TW is a tangent to the cyclic at W. Okay. Radii OR and OW, these two are drawn. So they are equal because they are both radius. W is equal to 25 degrees. Just ignore this. W is 25 degrees. W5 is 25 degrees there. That's W5. Okay, so now we are asked to determine and give reasons for the sizes of these angles. So for angle S1, okay, angle S1 is going to be equal to 25 degrees. The reason S1 is equal to 25 degrees is because this is 25 degrees and that angle there is because of the is 25 degrees because of the tan chord theorem. Remember the tan chord theorem? You have something like this, and then you have a circle here, and then you have this. If you have an angle here, that angle is going to be equal to that angle there. So I use that line of reasoning here. So now let's do the second one. O1. O1 is this angle here. We already know that this is 25 degrees, right? O1 is equal to 50 degrees. Why? Because it's twice that angle there. The angle at center is equal to 2 times the angle at the circumference. The angle, this angle here is going to be 50 degrees. Remember, this is 25. That has to be 50. Why? Because of this. Because they have a common segment RM. Let me draw it so that you can see it clearly. We have, oh my god, let me remove this. So we have something like this here. We have something like this. This angle at the center is twice that angle at the circumference. Okay, excuse my drawing there. So this is our center. The angle at center is twice the angle at the circumference. The angle at the circumference is 25. That one is going to be 50. The reason is angle at center is equal to 2 times the angle at the circumference. So let's go to R1. R1 is going to be equal to, where's R1? It's this one. This one is not going to be very straightforward. First of all, before we find it, we know that R1 plus R2 together plus that angle there, that 60 degrees there, are equal to 180 degrees. Why? Because angles opposite angles of a cyclic quad are supplementary. So I'll come back to this reason here to write it. I'll come back to it. So what other piece of information do we have? We don't know R2. R2, how can we find it? We know that this side OW is equal to OR, and we know that this is 50 degrees. So basically we have something like this here. We have OR, W, we have R2, and then we also have W3 and 4. This is 50 degrees. Because this side and this side are equal, these two sides are equal. So because the sum of the angles of a triangle are equal to 180 degrees, we can say 180 degrees minus 50 degrees is going to be 130 degrees. And then that 130 degrees is going to be shared by these two. So each one is going to be 65, 65, right? So we know that R1 plus this one, R2 is 65, right? So 65 plus 60 is going to be equal to 180 degrees. And then this is 65 plus this angle here plus 60 there. This is 125. And that angle is going to be equal to, let me make sure that I'm doing everything correctly, that I didn't miss anything. Okay, so if that was, okay, that's 180 minus 120, that's 60, that's 55. So that angle is going to be 55 there. Now, I will continue with this one on the next video because I planned to have this video only lasting 15 minutes. So basically, this is how you do the questions. The next video will be available soon, and I'll start here. It's D. Thank you for watching. Please subscribe. Thank you, thank you, thank you.